All right, let's solve another interesting question on shear force and bending moment, but we are going to be applying method of sectioning to solve the above question. All right, so here we are going to be drawing both the shear force and the bending moment diagram. All right, so for us to do that, the first thing we are going to do is to find the reaction at A and the reaction at B. You can see the distance from here to here is 3 meters. Here is 2 meters, here is 2 meters, while here is 3 meters, and the load given to us are 3 kilonewtons. All right, so we are going to take the sum of the vertical forces all to be equals to what? 0, and then we are taking upward force to be positive and downward force to be negative. All right, and our upward forces here is the reaction at A and the reaction at B. All right, so we are going to say reaction at A plus reaction at B will be equals to the sum of our downward forces. So it's going to be 3 plus 3 plus 3, which is going to be equals to what? 9. So if we make our reaction at A the subject, the reaction at A will be equals to 9 minus reaction at B. So let us call this one equation number 1. So the next thing we are going to do is to take the sum of moments about point A. So we are going to say summation of moments about point A should be equals to 0. All right. Meanwhile, our condition here still remain the same. Upward force positive, downward force negative. It means the moment produced by the upward force should be positive and the moment produced by the downward force should be negative. And what type of moment our upward force is giving us here? Look at our upward force is going in an anti-clockwise direction, while all our downward force is going to be going in what? Clockwise direction. It shows that anti-clockwise moment is positive while clockwise moment is negative. So here we are standing at this point, then we are taking our moment towards this side. So reaction at B multiplied by the total distance, we are going to have reaction at B multiplied by 10 minus 3 multiplied by this 3 multiplied by total distance is 7, then minus 3 multiplied by this 3 multiplied by total distance is 5, and the last 3 here multiplied by 3, everything equals to what? 0. All right, so here if we multiply this, we are going to have 10 RB. Then here we are going to have minus 21. Here we are going to have minus 15. And here we are going to have minus 9. Everything equals to 0. And if you sum everything here together, you are going to have 45. So we are going to have 10 RB to be equals to, so if you move it to the other side, you have positive 45. So here you divide both sides by 10. So here 10 will go with 10. Here our reaction at B will be equals to 4.5 kilonewton, while our reaction at A, will be equals to 9 minus RB, that is 9 minus 4.5, which is also 4.5 kilonewton. I hope we understand that. All right, so now the next thing is we are going to start with sectioning. All right, now if this is your first time of coming across this method, I will encourage you to check our previous video on sectioning method, where I have explained some concepts in other videos too. So but let's go now. For us to apply sectioning method here, the first thing you are going to check is all the point that we have load. From this point to this point we have load, from this point to this point we have load, from this point to this point there is load, while from this point to this one we don't have any load, right? So now in between the loads, you are going to have sectioning there. That is between this point and this point, you are going to have one sectioning. Between this point and this point, you have another sectioning. Between this point and this one, you have another sectioning. Between this point and this point, you have another sectioning. Some textbook, when you read them, you hear language like discontinuity. All right, but I don't want to be speaking all of those stuff here. I just want you to grab the concept. All right, so yeah, we are going to have 4 sectioning for us to solve this question. All right, so let's go for our first sectioning now. So we are going to section between, we are considering beam AC. So you section this part, section anywhere between point AC So along section X and S at a distance of S, at a distance that we don't know, so we are calling it S. All right, so we are going to draw out the beam here. So let's call it beam AC. So between beam, we are considering beam AC. Our beams look like when we section it. All right, so I told us now this is what you need to listen to this point. When you section a beam and when you cut out the part, this is the part that we section, that you section out from the point AC from the beam himself. You understand? So this is what it look like. So here we are going to have moment here, and then we are going to have a shear force, and we are also going to have a horizontal force. Do you understand? But because we don't have any horizontal force here, we are going to neglect any horizontal force. So we are going to have our normal force, and we are also going to have our moment. Do you understand? So the normal force here is the shear force. All right, so we are going to have our moment here, which is moment about section S, and then we are going to have shear force, which is denoted with what? V. So this is going to be downward. All right, so this is just the principle behind this method. All right, so now what we are going to do next is we are going to take our moment. We are taking moment about section SS, and we are equating it to be equals to 0. Here, upward force still remain as positive, downward force still remain as what? Negative. All right, so and it shows that the moment produced by our upward force here will be positive, the moment produced by our downward force here will be negative. All right, so here we are considering just moment about the section. So we are going to have our reaction at A here, which is an upward force, multiplied by the total distance. So we are going to have reaction at A multiplied by S. Then we are also having a moment going in this direction, that is going against this. If you look at this upward force here and you take our moment, is going in a what? It's going in a clockwise direction. Why this moment here is going in an anti-clockwise direction? So we are going to have minus n s, everything equals to what? 0. All right, so we are going to make this moment about point of the section to be the subject. If we make it at the subject, we are going to have ms will be equals to, so if we move it to this side, so we have ms to be equals to RAS. And don't forget, we have gotten our RA. Our RA is 4.5 kilonewton. So here we are going to have this to be 4.5 S. All right, so it shows that our moment here, our moment is 4.5 S. All right, so but we have gotten our moment, right, about the sectioning part. All right, now, so now the question is, how are we going to get this shear force? All right, the shear force is going to be gotten by differentiating the equation of our what? Our moment. You understand? So it shows that our shear force will be equals to d all over ds of n subscript s, which will be equals to d all over ds of 4.5 s. All right, if you differentiate 4.5 in respect to if you differentiate this in respect to s, you are going to have v to be equals to 4.5 kilonewton. All right, I hope we understand this. All right, so now we are done with the first portion. Now let's go for the second portion. Again, we are going to consider beam AD. Beam AD. Beam AD. All right. Oh, sorry, please. All right. So if we consider that we are going to set, we are sectioning this part. All right. So this is S. All right, so let's section it. Let's call it at a distance S1. All right. So let this be at a distance S1. All right. So if we bring out the part that we section here, now it's going to be all right. So if here is S1, here is 3, what will be the distance here? It's going to be S1 minus 3. So here we are going to have here to be S1 minus 3. So S1 minus 3. Okay. All right. All right, take note of that. So that's what we are going to have. All right, now we are going to have moments again about S. I'm also going to have a shear force. All right. So now, what the next thing we are going to do is we are going to take our moment about this section part. So we are going to have summation of moments about section SS to be equals to 0. Upward force is still positive, downward force is negative. All right, so here we are taking our moment towards this direction, so it's going to be ROA multiplied by total distance, which is S1. So we are going to have ROA S1. All right, so the next thing, we are having a downward force here, and this downward force here, if you look at the moment it's giving us, is different from the moment this one is giving us. This downward force here and this moment, they will be going in the same direction. So it means the moment produced by the downward force here will give you what? Negative, and this moment here will also be what? Negative. So it's going to be 3 multiplied by total distance. So negative 3 into S1 minus 3, then minus M subscript S, everything equals to 0. All right. So if you make our MS the subject here, we should just take it to the other side. So you can write this equation as M subscript S, that is the moment about the section part. It's going to be reaction at A, S1. Then if you open the bracket, you are going to have minus 3 S1 plus 9. All right, so let's substitute for our reaction at A. So it's going to be, we already know what our reaction at A is 4.5. 4.5 S1 minus 3 S1 plus 9. All right, so this will be equals to 4.5 minus 3, that is 1.5. 1.5 S1 plus 9. So this is the equation for our moment here. So how do we get our shear force? We are going to differentiate this equation in respect to what? S. So we are going to say our shear force is equals to D all over the S into what? Into M subscript S. So this is going to be D all over the S into 1.5 S1 plus 9. All right, so if you differentiate that, our shear force is going to be what? 1.5 kilo Newton. All right, if you differentiate, sorry, this is going to be in respect to S1. All right, in respect to S1. So if you differentiate this now, you're going to have 1.5. All right, so now the next thing we are going to consider is beam what? Beam A. We have considered AC, we have considered AD. So we are going to consider AE now. I'm going to consider beam AE. All right, so we are going to consider beam AE. So we are going to section this part. All right, so this is going to be about SS at a distance of S2 like that. So we are going to be using S2. All right. All right. So we are going to be using S2. All right. All right. So now, if we bring out the part now, we are going to have the beam to be in this form. All right. All right. So we have downward force here. We have downward force here. So we have 3 kilonewton. We have 3 kilonewton. All right. So this one is at what distance? This one is at 3. And this one is at 2, right? All right. So we have 3 AE. All right. So this one is at 3. The mouth of the marker is dry. It's drying up because of the breeze. All right. So here we have 3 meter here. Here we have 2 meter. So from here to here is 3, from here to here is 2, and from here to here is S2. So what will be the distance here? So the distance here is going to be S2 minus 5. So we are going to have here to be S2 minus 5. So just follow the process like this. You will arrive at your answer. All right. So you are going to have S2 minus 5. All right. So that's it. Now, we are going to do the necessary things now. So here we have our reaction at A. And here we are going to have moments. And we are going to have a shear force. All right, so that's it. Now, we are going to take our moment about these points now. So we are going to say summation of moment about the section part should be equals to 0. Again, upward force positive, downward force is what? Negative. All right. So, and the moment produced to will be positive and negative. All right. So now let's go. Here we are going to have, by taking the moment towards this side, it's going to be RA multiplied by what? S2. So we are going to have RA S2. All right. So here we are taking 3 multiplied by the total distance. So it's going to be minus 3 into what? Minus 3 into the total distance is going to be 2 plus what we have here. It is 2 plus S2 minus 5. All right. Then the next one is going to be minus 3 multiplied by this, minus 3 into what? S2 minus 5. Then the last but not the least is going to be the moment here, which is also going to be minus S. Everything will be equal to what? 0 minus M subscript S. Everything equals to 0. All right. So that's what we are going to have. All right. So the next thing we are going to do now is to make this MS the subject. So we are going to make our MS the subject. All right. So this will be equals to, so just take this to the other side. Everything here still remain the same. So let's just substitute directly. Our array is what? 4.5. So we are going to have 4.5 S2. All right. So here we are going to have 2 minus 3. Sorry, 2 minus 5. That is minus 3. So we are going to be having S2 minus 3 inside this bracket, right? So if we multiply that by minus 3, we are going to have minus 3 S2. Then inside the bracket we are having S2 minus 3. Minus 3 times minus 3. That is plus 9. All right. So now the next one is this. Minus 3 multiplied by S2 is minus 3 S2. Alright. So minus 3 multiplied by minus 5 is minus 15. No, it's positive 15 rather. Alright. So please don't do that silly mistake here. If you made that silly mistake, your work might not be correct. Your diagram might not be correct. While drawing your shear force and bend moment diagram, you might going to face some problems. Alright. So that's it. Now, the next thing we are going to do is let's simplify further. So this will be equals to, alright. So minus 3s, that is minus 6s. 4.5 minus 6, that is a 1.5 minus 1.5 s2. Alright. So 15 plus 9. 15 plus 9, that is 24. So we are going to have plus 24 here. So that will be the bending moment equation there. Alright, so the next thing we want to find here is our what? Is our shear force. Alright, so let's go for our shear force. So our shear force will be D all over what? The S of what? Of MS. So this will be equals to the differentiation of D into this. So which is minus 1.5 S2 plus 24. Or let's just say 24 minus, I say 24 minus 1.5 S. Don't know how this will contain it. Alright, 1.5 S2. So if you differentiate that, we are going to have minus 1.5 kilonewton. Alright, so that will be our shear force. Alright, so the next thing we are going to consider here is beam AB. Beam AB. Alright, so the full beam itself now, let's consider it. So now, next thing we are going to section this side. Or section any part there. Alright, so this is SS. Alright, so we are going to call this distance to be S3. Alright. Alright, so this is going to be S3. Alright, so if we consider that part now, if we bring that part here, we are going to have our beam like this. You have here to be 2 meters. Sorry. Have here to be 2 meters. Also have here to be 2 meters. Alright, so here is also 2 meters. Alright, so if here is 2 meters and the total distance is S3, right? Everything is S3. Right. So the total distance from this point is 7, right? Yeah, 7. And the whole length is S3. So it shows S3 minus 7. So here is going to be S3 minus 7. Alright, so let's just, so here we are going to have, alright, so here we have 3 kilonewton, 3 kilonewton, and 3 kilonewton. Alright, so now we are going to have moment there, right? We are going to have moment and shear force. So we are going to have moment and then we're also going to have shear force. All right. So let's take our moment about this point, that is the summation of moment about the section part, SS will be equals to 0. Don't know how this will contain it because I want everything to be on the board. So if I want to draw the shear force and bending moment, you understand everything clearly. So I need to manage my space. So we are going to have arrow S, arrow multiplied by S3. Then others will be minus. So this point to this point, this minus 3 multiplied by the total length here. So here is going to be minus 3 into what? Into 2 plus 2 is 4. That is 4 plus S3 minus 7. Alright. So here minus 3 into what? Into 2 plus what we have here. So this is going to be 2 plus S3 minus 7. And here we are going to have minus 3 into minus 3 into, let me just say, minus 3 into S3 minus 7, then minus ms equals to what? 0. All right. So a quick one. Let's just if we move our ms to the other side, our ms will be equals to, all right, this one is, our arrow is 4.5, right? So we are going to have 4.5 S3 here. All right, so let's see, maybe we can do this directly. 4 minus 7, that is minus 3. So here we are going to be having S3 minus 3, right? And if we multiply by minus 3, we are going to have minus 3 S3 plus 9. All right. Here we are going to have 2 minus 7, that is minus 5. So we are going to have S3 minus 5. So we are going to be having, if we multiply that by minus 3, we are going to be having minus 3 S3. Then minus 3 multiplied by minus 5 is positive 15. All right. So here, if we multiply this, we are going to have minus 3S minus 3S3, then plus 21 equals to what? 0. All right. So now, if you add all of this stuff here, we are going to have 4.5 minus 3 plus 3 is 6 plus 3 is 9, right? We are collecting the like terms now. This is S3 here, S3 here, S3 here, S3 here. So 3 plus 3 is 6 plus 3 is 9. 4.5 minus 9, that is 4.5. So we are going to have our ms to be equals to 4.5 S3. Okay. So 9 plus 15 plus 21, that will give us 45. So we are going to have positive 45. All right. So now, that is the equation of our moment here. So now, let's find our shear force now. Shear force will be the differentiation of our moment of equation here, which is 4.5 S3, 4.5 S3. Sorry, I made a mistake here. Minus 3 minus 3 minus 3, that is minus 9. 4.5 minus 9 is minus 4.5. Minus 4.5. All right. So plus 45. All right. So if you differentiate that now, the value of our shear force here will be minus 4.5 kilonewton. Yeah. I'm happy. Everything is now on the board. So I hope we understand all of this analysis, how we got all the shear force value and the bending moment equations for each of the section. There are 4 sections, right? Yes, 4 sections. So now the next thing we are going to be doing now is you are now going to learn how you are going to draw the bending moment and the shear force diagram. So, and you know, according to the rule, the shear force and the bending moment diagram must be under the beam himself. So I will need to clean this side. We don't need anything here again. So the only thing we might need here is reaction at A and reaction at B. And then we already know what there is, 4.5, 4.5. So I will need to clean this side so I can draw that. Let's draw the shear force and the bending moment diagram. All right. If you have been following our work on shear force and bending moment, you know anywhere we have load, we're going to draw a vertical line downward. And then we are going to be drawing an horizontal line for our shear force diagram and an horizontal line for our bending moment diagram. So at this point, it will be 0, 0, 0, and 0. So the first line here is the line for our what? Our shear force diagram. While this line here is the line for our what? Our bending moment diagram. And above and below this both line is positive and what? Negative. So above this line is positive, below is negative. Above is positive, below is negative. All right. So now, let's get into work. All right. So for us to start with the shear force, now we start the sectioning of our beam from the left hand side to the what? To the right. So it shows that our shear force diagram will also start from this left hand side. All right. So and for us to draw our shear force, we are going to consider beam AC first. And you can see beam AC. And then what was the shear force value there? The shear force value there is what? 4.5 kilonewton. So it means you are going to come to this point here, and then you are going to trace 4.5 upward. So I'm going to go 4.5. 4.5. So let's just call this, let's mark here to be 4.5. So you are going to join this line here. All right, so let's call this place to be our 4.5. All right, so if this point here is our 4.5, between A and C, do we have any other force? No, so we don't have any other force. So it means we are going to have a constant line here. So we are going to have a constant line. All right. You may want to write 4.5 here. You understand? But I don't think there's need to write that. All right. But in case of exam purpose, you can write it. You should write it from this point to this point. So you just write 4.5 here. And now, for us to proceed, now if you look at point C now, we are having 3 kilonewton, right? Now, from this point to this point is 4.5. So now, and it is a downward force, right? Don't forget, we said our downward force should be what? Negative, while our upward force should be positive, right? So now, it means that the 4.5 that we have here now, we are going to subtract it from 3 kilonewton. You understand? 4.5 will be subtracted from 3 kilonewton because our downward force is negative, while our upward force is positive. You can see our force that we have here is upward. That is why the value for our shear force here is 4.5. That's why we trace it upward. Do you understand? All right. So now 4.5 minus 3 is going to give us what? 1.5. So we go down 1.5. So let's say if from this point to this point 4.5, definitely 1.5 should be somewhere around here. Sorry, my marker is drying up because of the breeze. All right. So definitely we should have 1.5 somewhere here. All right. So here I'm going to take our ruler and we are going to join this line. All right, so that is our 1.5, and between this point and this line we don't have any other force, so we're also going to have a constant line here. All right, so that's it. Now we have 1.5 here, so we're also having a downward force here, right? So 1.5, to subtract 3 from 1.5 again, that is 1.5 minus 3. 1.5 minus 3 is going to give us minus 1.5, right? So it means we are going to the negative part now. We are going to trace 1.5. Don't forget, this line here is 0, right? So between 0 and negative 1.5. So let's take negative 1.5 to be somewhere around there. All right. So now we are going to join. We are going to join the point now. All right. So now if you look at this, from this point to this point, now we don't have any other force, right? So we are going to have a constant line here. Don't forget it's negative 1.5. All right. Now we are having negative 1.5. Don't forget we are having a downward force here. So it's going to be negative 1.5 minus negative 1.5. So that is going to give us what? Negative what? 4.5. So for this point again, we are going down negative 4.5. Don't forget, from this point to this point is what? 1.5. So we are just going to add 3.5. RDB it is a graph, right? So I'm just going to add 3.5 to it to have 4.5. So let's just take this point to be our 4.5. All right. So let's just take this point. I don't want it to be too bigger than the first one. So it should be almost perfect. All right. Sorry, please. All right. Let me draw this. All right. So now from this point now, if we go back to 0. All right. So now we can therefore shade now. Can shade. All right. All right. All right. Please always make your work to be very neat. All right. So the reason why we are shading this is if we have a graph now, you know, in a graph we always have lines everywhere. So it's just to trace out the points, the part where your shear force diagram is. So and I also just love shading my work to make my work to look beautiful and good and okay. All right. All right. All right. So that's it. So this top part here is positive, while this down part here is negative. All right. So from this point here we have negative, from this point here we have positive. So that is the shear force diagram. All right. Now the next thing is the bending moment diagram. All right. So now for us to draw our bending moment diagram, here you are now going to be taking very important note here, because it might be confusing sometimes, but it is very easy. All right, let's go. Easy peasy. Now if you consider beam AC, the bending moment equation there is what? 4.5 S, right? So what is the value of S? Now if you check beam AC, the total distance that we have there is 3. At point A, what is the value of S there? The value of S at point A is 0, right? So it means if you want to get the bending moment at point A, the value of S will be 0. Do you understand? So we are just going to substitute S to be 0 here, and we are going to get the bending moment at point A. If you want to get the bending moment at point C, we are going to substitute the value of our S to be what? 3, because from this point at point C, the value of S is 3. So we are going to substitute 3 in this equation. Then we get the value of what? The value of point, the value of the bending moment of point C. But now if you want to get the bending moment at point D, are we still going to be using are we going to be using beam AC? Of course, no. So once you are done with AC like that, it means if you want to get the bending moment at point D, you cannot apply you cannot apply this beam AC. So you are going to go to beam what? Beam AD. So for beam AD, for you to get the bending moment at point D, the total distance there is just what you are going to calculate there. From this point to this point is 5. So it shows that the value of our S is going to be 5. Then you are going to substitute 5 in the bending moment equation that we have here. And by the time you do that, you will get your value. Exactly. So let's do that now. All right. So now let's go for the bending moment at point A. For us to do that, we are considering this moment equation. And at point A, the value of S is 0. So if you put 0 here, 4.5 multiplied by 0 is what? 0. So it shows that our bending moment is going to be 0, which is at this point. All right, let's go. Now, for us to get the bending moment at point C, we know that the total distance here is 3. It shows that the value of S there is going to be 3. So if we put 3 here, you are going to have 4.5 multiplied by 3. 4.5 multiplied by 3 is what? 13.5. So we are going to, from this point, we are going to trace 13.5 upward. So let's take this point to be our 13.5. So now, since we are having an horizontal line here, we are going to be having an inclined line. So we are going to join these 2 points with an inclined line. All right. So now the next one, we'll be going to beam AD. Now when we get to beam AD, we want to find the shear force at point D. We are done with the shear force at point A, the shear force at point C. We just need the shear force at point D. All right, so for us to get the shear force at point D, we must know the total distance, right? So the total distance from this point to this point is nothing but what? 5. So we are just going to substitute 5 in the bending moment equation. So it shows that S1, the point here, that is S1, right, is 5. So we are, yes, S1 is going to be 5. So now it shows that the value of our S1 is 5. So it's going to be 1.5 multiplied by 5 plus 9. If you do that, you are going to have 16.5. So here, we are going to trace 16.5 upward here. So let's trace 16.5. From this point to this point is 13.5. Definitely 16.5 should be somewhere around here. All right. So we are going to use an inclined line. Again, we are having a constant line here. We are going to be using an inclined line to join this point and this point. All right. All right. So that's it. All right. So now we want to get the bending moment at point E. So we want to get the bending moment at point E. All right. We don't have anything E here again. We don't have anything to do with this part again. So we are going to go to beam AE where we have point E. All right. Now, so for us to get that, the total distance, that our S3 here, our S3 from this point to this point, what is the value of our S3? Our S3 is going to be what? Our S3 is going to be 5 plus what? Plus 2, which is what? 7. So we are going to substitute, we are going to make S3 in the bending moment equation, coming point AE. Okay, we are using S2 here rather. So in the first one it was S1. Sorry, it means I made a mistake. AD. So the value of our S1, please, S1 is what is 5 here. So it is 5. So 1.5 multiplied by 5 plus 9. So S1 there is going to give us 16.5. All right. So now for us to get the bending moment at point E, so now we are going to consider the total distance here, which is what? 7. So we are going to go to the bending moment equation here. So we are going to replace our S2. S2 there is 7. So negative 1.7, 1.5 multiplied by 7 plus 24. You are going to have 13.5. 13.5. So don't forget, 13.5 from here is 16.5. So don't forget, already from this point to this point is 13.5. So 13.5 we will be at the same distance with what we have here, right? All right. So let's take it to be somewhere around here. All right. So we are going to be using an inclined line since we have a constant line here too. All right. And see, this is very easy. It's an easy peasy work. All right. So that's it. All right. So now I want to get at point B now. At point B, the total distance there is what? Is 10. All right. So now for us to get bend moment at point B, where are we going to? We are going to go to beam A, B, where we have B. So now the bending moment equation here is negative 4.5 S3 plus 45. So if we put if we substitute 10 here, we're going to have negative 4.5 multiplied by 10, which is going to give us what? Negative 45. And negative 45 plus 45 is what? 0. So it means that we are going back to 0. So this is going to come down here. All right. So now we can therefore shade now. So we are going to shade. How can we shade this very fast? Just shade it for the sake of our time. All right. All right. So it is very easy. So most of our video, we use direct method. So it was a student that requested for this method. So, and I'm very happy that I come across this. I'm sharing it with you guys. So please, always share our content with your colleagues in the engineering faculty. That this course might be useful for them, and with your friends studying civil engineering. And we're also going to go into electrical course and mechanical courses. So we are touching all aspects of engineering. All right. Sorry. So here is positive. Everything here is positive. All right. So if you are asked what is the point of contraflare in this question, what will be the point of contraflare? What is point of contraflare? Point of contraflare is the point where bending moment diagram changes in sign, either from positive to negative or from negative to positive. So here we don't have any changes in sign in our bending moment diagram. So it shows that we don't have point of contraflare, or point of contraflare is what? None, or what? 0. All right. So this is how to go about the solution of this question, and this is just how to solve this question using sectioning method. All right. So I believe you have understand this. Please let us know that in the comment section, and let us know how well we are going with our lectures on sectioning method. So please, if today is your first time of coming across our content, don't forget to hit the subscribe button, and don't forget to hit the notification bell so that anytime we upload a video like this, you'll be the first to receive the notification. And don't also forget to click on the join button. Immediately you click on the subscribe button, you see join. You join our membership program, our membership group, where you are going to have access to what? More premium content that like the one you just watch. And don't forget to share this, to always share our content with your friends who might be in need of this, who are in the engineering department with you, and in other schools too. You can share with them. So let's